There's another really important concept that we need to understand about polynomials, and that concept is the conjugate root theorem. The conjugate root theorem tells us that complex roots, both imaginary and irrational, come in conjugate pairs. Remember, we talked about conjugate pairs when we talked about the difference of two squares or the sum of two squares. But let's take another look. When we have irrational conjugates, what that means is that we have a plus the square root of b and a minus the square root of b. Those are conjugates. Notice that the sign of a didn't change. It's the sign of the second term in this complex conjugate that changes. What about the square root of b and negative square root of b? They are also conjugates. So if a plus the square root of b is a root of a polynomial or a factor of our polynomial, then a minus the square root of b is also. Imaginary conjugates then are a plus bi and a minus bi, or even just bi and negative bi. These are conjugate pairs. So if one is a zero of our polynomial, then both are zeros of our polynomial. Let's take a closer look at what this means. I'm given two roots of a polynomial. One is 2i and one is the square root of 10. That means that I actually have two more roots to this polynomial. So I want to find the missing roots, and then I'm going to actually find polynomial p of x. First, I want to think about this. What is the degree of this polynomial? Well, remember we said that if we were given imaginary roots, they have to come in conjugate pairs. Irrational roots also come in conjugate pairs. So let's talk about this. We want to find all the roots. Well, we know the roots that were given, and we know they come in conjugate pairs. So that means if negative 2i is a root of our polynomial, then 2i is also a root of the polynomial. And if the square root of 10 is a root of our polynomial, then negative square root of 10 is also a root. That means if I have 4 roots, then my polynomial has to have a degree of 4. How do I find the factors? Well, I take the roots, change the sign, and stick an x in front of it. That's my factor. So in other words, if negative 2i is a root of my polynomial, then x plus 2i is a factor of my polynomial. And if 2i is a root of my polynomial, then x minus 2i is a factor of my polynomial. If the square root of 10 is a root of my polynomial, then x minus the square root of 10 is a factor of my polynomial. And if negative square root of 10 is a root of my polynomial, then x plus the square root of 10 is a factor. Now I found all 4 factors of my polynomial. So how do I find p of x? Well, I multiply the factors. But remember, conjugates form the difference of two squares. In other words, x plus 2i times x minus 2i is a conjugate. So this would be the difference of two squares, but remember, I squared is equal to negative 1. So really this becomes the sum of two squares. So I get x squared plus 4. If you don't remember that pattern, I suggest you take another look. All right, what about x minus the square root of 10 times x plus the square root of 10? Well, x minus the square root of 10 times x plus the square root of 10. This is definitely a difference of two squares. So I take the first term and square it, x squared. Subtract, that's my difference. And I take the second term, the square root of 10, and square it. What is the square root of 10 squared? It's 10. Well, look at this. Now I have two factors, x squared plus 4 and x squared minus 10. So what I want to do is multiply them together to get p of x. So I'm going to do that. And you could use that dreaded term FOIL but I'm going to do it vertically instead of horizontally. This allows me to make sure that all the correct terms are lined up. Makes it a little bit easier to add. So I'm going to take negative 10 and multiply it by 4. You get negative 40. And negative 10 times x squared is negative 10x squared. Then I take x squared times 4, so that's 4x squared. And x squared times x squared is x to the 4. And now I add like terms. X to the 4, negative 10x squared plus 4x squared is a negative, not a positive. It's a negative 6x squared, and then I have negative 40. And this is my polynomial p of x.